So good morning, welcome to Sakal Vidya YouTube channel. Okay, today we talk about multiplication of matrices regarding to the Diploma Basic Engineering Mathematics first year semester 1 classes. So today is the very important topic. So this is very important for the matrices chapter, multiplication of matrices. So today we talk about multiplication. Good morning, Kishore. Multiplication of matrices. So that means how do you multiply the two matrices? So can we multiply the two matrices directly or any conditions are there? Any conditions need to be satisfied. But moreover, regarding to the multiplication of matrices, you must remember that so we should actually the two matrices are said to be conformable for multiplication if and only if the number of columns of first matrix should be equal to the number of rows of the second matrix. Then only the two matrices are said to be multiplied one each other. So that means in order to multiply the two matrices, first of all, the first and foremost condition. So good morning. Here, uh, the number of columns of first matrix is equal to the number of rows of the second matrix. Then only we can multiply. Otherwise, that is called multiplication of matrices is product of the matrices. The product of the matrices is not defined. So that means we need to write like this. Two matrices are said to be conformable 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 for multiplication multiplication if and only if the number of Rutvik the number of columns of the first matrix is equal to the number of rows of the second matrix. So that means otherwise the product is not defined, the multiplication is not defined. Two matrices are said to be conformable for multiplication if and only if this condition: the number of columns of first matrix is equal to the number of rows of the second matrix. Suppose here you see, if A is a matrix of order m by n and B is a matrix of order of order n by p, then the product is also a matrix. The product AB is a matrix of order m by p, because you check here number of columns n of the first matrix A, number of rows of second matrix B, so that AB is defined. The order of AB also we can expect, that is m by p. M, this means actually the AB is consisting of m rows and p columns, m by p. So that means you remember like this. For example, A is the order of m by n and B is a matrix of order of n by p. So you check now, here n, here number of columns n, number of rows n. So AB is defined. And whose order is like this? So AB is a matrix of order m by p. You will get it. This is the resulting matrix. So now how to multiply? Let us see now here. So method. So let us discuss method to find product of two matrices. So first actually procedure you check here now. For example, the first matrix is considered like this: R1, R2, row 1, row 2. So multiplied with, here we have C1, C2. Actually we adopt row by column multiplication. So how to multiply? Let me explain here. See, R1 into C1 you need to write. So this is equal to, first you get like this: R1 C1, next R1 C2, next R2 C1, next you need to multiply R2 C2. So this is one type. So let me give the example. What is n by p? Means order n rows p columns, n rows and p columns in that matrix. Okay, now I discuss one example here. Example, if you want to multiply, how many rows are there? 2 rows there must be. 2 rows means actually, see, for example, here 2, 3, 1 row, 4, 5, second row. Multiply with some 1, 2, 3, 4. How to find out product of these two? See, first, what is the condition? R1 into C1. First you take R1. This is R1 into C1. So how to multiply? R1 into C1 means now 2 into 1 plus 3 into 3. First we need to write. So next R1 into C2. How to write? 2 into 2 plus 3 into 4. Next R2. Take R2. This is R2 into C1. R2 into C1 means 4 into 1 plus 5 into 3. Next, R2 into C2, 4 into 2 plus 5 into 4. See, here you get like this. 2 1 ja 2 plus 9, 2 2 ja 4, 4 3 ja 12, 4 1 ja 4, 5 3 ja 15, 4 2 ja 8, 5 4 ja 20. So this equals to, we get 11, 16, 19, 28. So this is 2 by 2 matrix, 2 by 2 matrix, we get a 2 by 2 matrix. So shortcut for multiplication, this is the shortcut for multiplication. Wait, now we just started. Now second example, you go for second example. Row 1, row 2, row 3 multiplied with the C1, C2, C3. So how to multiply? See, first R1 into C1, R1 into C2, R1 into C3. Take first, second row, multiply with the 3 rows and write down as a row. Second row, R2 C1, R2 C2, R3 C3, R3 C1, R3 C2, R3 C3, R3 C3. So let us do one example. Now example. So product of 3 by 3 matrices 1, 2, 3, 0, 1, 1, 2, 1, 0 multiplied with 1, 0, 1, 2, 1, 0, 0, 0, 1. So if you want to multiply these two matrices, how could you multiply? Let us see how to multiply. First, you take R1, this is called row 1, multiply with this column 1. So how to write? You see, 1 into 1 corresponding 1 into 1 plus write down 2 into 2 plus 3 into 0. Next R1, this R1 C2, 1 into 0 plus 2 into 1 plus 3 into 0. Next R1 C3, 1 into 1 plus 2 into 0 plus 3 into 1. So the first row of the product matrix is completed. Now go to R2. You take R2 with C1, C2, C3. R2, C1, R2, C2, R2, C3 you need to write. 0 into 1. This is 0 into 1 plus 1 into 1 plus 1 into 0. Next 0 into 0 plus 1 into 1 plus 1 into 0. Now R2 into C3, 0 into 1 plus 1 into 0 plus 1 into 1. Thank you. Good morning all. Good morning. Dhanalakshmi. Happy Pongal. So now you take R3 into C1, C2, C3. So now you can write like this: 2 into 1 plus 1 into 2 plus 0 into 0. Next 2 into 0, 1 into 1 plus 0 into 0. Next 2 into 1 plus 1 into 0 plus 0 into 1. So now you need to simplify. 1 into 1, 1 plus 2 into 2, 4, 3 into 0, 0. 1 into 0, 0 plus 2 into 1, 2, 3 into 0, 0. Oh, very good. Mahmoud Basha. 1 plus 0 plus 3. Now 0 plus 1 plus 0. 0 plus 1 plus 0. 0 plus 0 plus 1. 2 plus 2 plus 0. 0 plus 1 plus 0. 2 plus 0 plus 0. So this equals to, we get 5, 2, 4, 1, 1, 1, 4, 1, 2. This is the matrix. So I hope you might have followed. Definitely I will start Eamcet classes. Compulsory. Okay. So now let us discuss the properties of the properties of the of multiplication on matrices. Okay. First example. You consider first example here. First example. First question. If A equals to 1374 and B equals to 6532, then find first AB, A into B AB, second B into A BA. What do you observe? What do you observe, or what do you notice? From this we get one of the properties, important property. Right, you did not said properties of subtraction. Okay, leave it. So that is not necessary, Nana, now present. If A is equal to 1374 and B is equal to 6532, then find AB and BA, and what do you notice? So that let us find out now. See, solution. Here given A equals to 1374 and B equals to 6532. First question. Let us find out AB, product of AB. So can we multiply A and B? Can you find AB? Because it is 2 by 2, it is 2 by 2. So that we can get 2 by 2 matrix of order AB itself only, so that they can be multiplied. The first is 1374 multiplied with 6532. Product of two matrices is also a matrices. Row column method you need to follow. So that means actually here first row, first column 1 into 6 plus 3 into 3. Am I correct? First row, second column 1 into 5 plus 3 into 2. Yes, Mahmoud. Next, second row 7 4 6 3. 7 into 6 plus 4 into 3. 7, 4, 5, 2. 7 into 5 plus 4 into 2. So let us simplify. Now what do you get now here? 1 into 6, 6 plus 3 into 3, 9. 1 into 5, 5 plus 3 into 2, 6. 42 plus 12. 35 plus 8. So now 15, 11, 54, 43. This is AB. This is AB. 35 plus 8, 43. You check Muhammad. 54 and 43, not 38. Not 38. See, 4 into 2 is 8. 30. 7 into 5, 35. 35 plus 8 is 43. 43. Right. So next now go to second one. Second one is BA. So now the B matrix. What is the B matrix here? We have 6, 5, 6, 5, 3, 2. 6, 5, 3, 2. So multiplied with the A. What is A? 1374. 1374. Okay, let us find out now. Now, first row, first column. 6 into 1 plus 5 into 7. First row, second column. 6 into 3 plus 5 into 4. Yes. So now the second row, first column. 3 into 1 plus 2 into 7. 3 into 3 plus 2 into 4. So now this equals to 6 plus 35, 18 plus 20, 3 plus 14, 9 plus 8. This equals to 41, 38, 17 and 17. Yes, absolutely correct, Nana. So this is, so now we notice that AB is not equal to BA. Therefore, matrix multiplication is not commutative. It is not necessary that AB equal to BA. AB is not equal to BA. But note, write down, sometimes letter A comma B are be two matrices such that AB is equal to BA, then A and B are said to be commute. It will be useful for Eamcet examination or entrance examinations. These are very important. Okay, now let A and B two matrices such that AB is equal to BA, then A and B are said to be commute. And one more thing also you remember, if A and B are commute, then AB is equal to BA. Whenever if you observe this kind of statement, then we need to observe that here AB is equal to BA. AB is equal to BA. Right. Let us go for second example. Second example. If A equals to 1374, B equals to 1011, and C equals to 1121. Next, then find first one B plus C, second AB, third AC, fourth then A into B plus C. What do you notice? What do you notice? This is the question. You try this question. Solution. First question B plus C. It's very easy. 1011 plus 1121. You know how can they be added? So 1 plus 1 2, I am writing directly. 0 plus 1 1, 3 2. Am I correct? B plus C this is. Second AB, product of A and B. 1374 B 1011. Okay, so now R1 C1, 1 into 1 plus 3 into 1, 1 into 0 plus 3 into 1, 7 into 1 plus 4 into 1, 7 into 0 plus 4 into 1. So this equals to 1 plus 3, 0 plus 3, 7 plus 4, 0 plus 4. This equals to 4, 3, 11, 4. This is AB. Okay, can you find out now AC? Third one. Let us find out AC. Go back. 1374 1374 multiplied with C. Go to the previous page. C is 1121. 1121. So let us multiply. Now what do we get? Could you help me? First row, first column. 1 into 1 plus 3 into 2. First row, second column. 1 into 1 plus 3 into 1. Second row, first column. 7 into 1 plus 4 into 2. Next 7 into 1 plus 4 into 1. Okay, this equals to 1 plus 6, 1 plus 3, 7 plus 8, 7 plus 4. This equals to 7, 4, 15, 11. Am I correct? Now what we need to find out now here? A into B plus C also, fourth one. Fourth one. A times B plus C matrix. See, A matrix is 1, 3, 7, 4 into B plus C matrix. What is B plus C? B plus C is equal to 2, 1, 3, 2. 2, 1, 3, 2. So now let us multiply 1, 3 into 2, 3. 1 into 2 plus 3 into 3. 1, 3, 1, 2. 1 into 1 plus 3 into 2. 7 into 2 plus 4 into 3. 7 into 1 plus 4 into 2. Okay, let us simplify. Let us simplify. Now what do we get? 2 1 ja 2, 3 into 3 9, 1 plus 6, 14 plus 12, 7 plus 8. Now this equals to 11, 7, 26, 15. Say this is equation 1. Now I have forgotten to ask you, now AB plus AC also. Fifth one, find AB plus AC. AB plus AC. AB plus AC. Both the matrices need to be added now here. Let us see what do we get now. Let us see what do we get. AC is 7, 4, 15, 11. 7, 4, 15, 11. Now AB, 4, 3, 11, 4. 4, 3, 11, 4. 4, 3, 11, 4. So what do you get now here? 4 plus 7 is 11. 3 plus 4 is 7. 11 plus 15 is 26. 4 plus 11 is 15. Say equation 2. Observe equation 1 and 2. 11, 7, 26, 15. 11, 7, 26, 15. From 1 and 2, we notice that therefore A of B plus C equal to AB plus AC. AB plus AC. So that means A into B and A into C plus AB plus AC. This is called left distributive law. Left distributive law. left distributive law. So that means matrix multiplication is distributive on addition. So that means first property is first one, A of B plus C equals to AB plus AC. Second, B plus C of A, this is right, BA plus CA, but don't write AB and AC. This is called right distributive law. Now third example. Let us discuss third example. If A equals to 1020 and B equals to 000357, then find AB. What do you notice, or what do you observe? What do you notice? So your observations need to be noted down. So what do you notice? So now A equals to 1020 and B equals to 00357. This is 2 by 2 matrix. This is 2 rows 3 columns, 2 by 3. You check now. Number of columns of A is equal to number of rows. They are conformable for multiplication. We can multiply. Its order becomes 2 by 3. 2 rows and 3 columns we will get it, resulting matrix. So that first we need to visualize it. The order of the product of A and B, that is 2 by 3 you will be getting. Solution: given A equals to 1020 and B equals to 000357. Now AB, we are going to find out product of the two matrices A and B. This A equals to 1020 multiplied with 000357. So you remember this is row 1, row 2. So generally you have the structure like this: row 1 R1 R2 multiplied with C1 C2 C3. First column, second column, third column. What do you get? R1 C1, R1 C2, R1 C3, R2 C1, R2 C2, R2 C3. That we need to write it. So that means we are going to get like this: R1 C1, R1 C2, R1 C3. Next R2 C1, R2 C2, R2 C3. R2 C3. Applied maths. Okay, Rohit Kumar. Right. So now see what do you get now here? R1 C1, 1 into 0 plus 0 into 3. R1 C2, 1 into 0 plus 0 into 5. R1 C3, 1 into 0 plus 0 into 7. Now R2 C1, 2 into 0 plus 0 into 3. 2 into 0 plus 0 into 5. 2 into 0 plus 0 into 7. Now what do we get it? Let us write it now. Okay, I will go through it, Nana, Rohit Kumar. So now 1 into 0, 0, 0 into 3, 0, 0 plus 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 0. So you will be getting 0, 0, 0, 0, 0, 0. This is null matrix, zero matrix of order 2 rows and 3 columns. That means AB is equal to, indirectly we get 0. Now what do you observe? See, if you check, A is not a null matrix, B is not a null matrix. Though they are not null matrices, their product may be null matrix. It is not necessary that AB is equal to G. O means null matrix means A does not equal to O and B does not equal to O. It is not necessary that both need not be null matrices, that we can confirm. So let us write important note. So what is the important note means? If AB is equal to O, null matrix, then A or B need not be equal to O, that is null matrix. This is the important result. This is the important result. Right. Next. So let's have a discussion on fourth example. Fourth example. If A equals to 1101, B equals to 2310, and C equals to 1011, then find first one AB, second BC, third AB into C, fourth A into BC. What do you observe? What do you observe? What do you observe? So can you solve this question? Can you solve this question? Can you solve this question? So now let us move to the next page. Okay, these are the given matrices. So now the solution given. First let us find out AB. 1101 multiplied with B 2310. So directly shall I do it? Independent gaming, hi, welcome. So now you see 1 into 2 2 plus 1 into 1 1, 1 into 3 3, 1 into 0 0. Now 0 into 2 0 plus 1 into 1 1, 0 into 3 0, 1 into 0 0. This equals to, we get 3 3 1 0. This is AB. Okay, second one now. Let us find out BC. 2310 multiplied with 1011. So now 2 3 into 1 1, 2 into 1 2 plus 3 into 1 3, 2 into 0 0 plus 3 into 1 3, 1 into 1 1 plus 0 into 1 0. Thank you, thank you. Now 1 into 0 0 plus 0 into 1 0. Now you get this equals to 5 3 1 0. This is BC. Now go to third example. AB into C. AB into C. What is AB matrix now? AB matrix is equal to 3 3 1 0 multiply with C. C is 1 0 1 1. Now this equals to 3 3 into 1 1, 3 plus 3, 3 3 into 0 1, 3 into 0 0, 3 into 1 3, 1 0 1 1, 1 into 1 1 plus 0 into 1 0, 1 into 0 0 plus 0 into 1 0. Now you get 6 3 1 0. This is AB into C. Next, now the fourth one is A into BC. What is A? 1101 multiplied with BC. BC is 5310. So now what do we get now? What do we get? So 1151, 5 plus 1, 3 plus 0, 0 1 into 5 1, 0 plus 1 into 1 1, 0 into 3 0, 1 into 0 0. You get now 6310. Now what do you observe from these two? AB of C equal to A of BC. This is called associative property. So therefore we can write, we observe that AB of C equal to A of BC. So that is matrix multiplication is associative. This is the property. Okay, this is one of the properties actually we have discussed. So but they are provided that they are conformable for multiplication. Provided that They are conformable for multiplication. Right. Example 5. Before going to example 5, we need to discuss some more points also. See, if A comma B comma C are three matrices such that AB is equal to AC, then it does not imply that B is equal to C. That means cancellation law does not hold good on matrix multiplication. For example, if A comma B comma C are matrices and AB is equal to AC, we should not cancel like this. AA, don't cancel it. That means cancellation law does not hold good on matrix multiplication, just like algebra. In algebra, we can gets cancelled, but for example, in algebra, like is there, AB is equal to AC, AA gets cancelled, we get B is equal to C. But in matrices, AB is equal to AC, so we should not write like this. It's absolutely wrong. Next, one more property we need to discuss. Let A be any matrix, then A into I equals to I into A equals to A. Here I is called identity matrix. Harshvardhan. One more. Let A be a square matrix. A be a square matrix and N be a positive integer. Then see the first point. So that means powers of A we are going to discuss. A square. What is meant by A square? A square is nothing but A multiplied by A. A into A. Second one, how to find out A cube? A cube is equal to A square into A. First we need to find out A square, then multiply with A. So A power 4, A raised to 4, A cube into A. Now A power 5, that is A power 4 into A. And therefore, for example, if you want to find out A raised to N, that is A raised to N minus 1 or N plus 1, A raised to N plus 1 is equal to a raised to n into a. And also this follows this law also. A to the power of m into a to the power of n. We can write a to the power of m plus n. This holds good. Next, one more thing. For example, a to the power of n is equal to I if n equals to 0. So you remember this one. Now fifth question. If a equals to 7891, then find a square. Find a square. This question was given in March 2016. So now whenever A is a square matrix, then only we can find out A square and A cube and A power 4 like that. A must be square matrix. This is 2 by 2, so that we can find out A square. So now how to find out? See, here given, first step write down A equals to 7891. So now A square, by the definition A square equals to A into A. So that is equal to 7891 multiplied with 7891. So this is equal to 7879. 7 into 7 49 plus 8 into 9 72. 7 into 8 56 plus 8 into 1 8. 9 into 7 63 plus 1 into 9 9. 9 into 8 72 plus 1 into 1 1. Now let us add. This is 11, 12, 121, 64, 72, 73. This is A square. A square is also a matrix. Okay, thank you. Tomorrow we shall continue in the session. Bye bye.